All right, so assuming I haven't made any mistakes or anything like that, which hopefully knock on wood, it looks like my test statistic is going to be 13.106, which is pretty big. So this is looking pretty good that the distributions are not the same. And another thing that kind of shows up here that kind of helps determine, because remember, that's kind of the nice thing about if we do it this way, you can sort of figure out which one is going to be, which one is making this such a big number. Because in a perfect world, like if the distributions were basically the same, our chi-square number should be relatively small. So if you look at these fractions, notice the first one, 1 over 9 over 255. So if we add two things together that are about the same size, that's going to give us something relatively close to 1. Same thing, 18.86. So they're closer together, but these are kind of the ones where we can see that's going to make these numbers jump up really, 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 really big. And so in this case, this goes back to this column, which if we remember, what was that? Military. So it looks like the military is really the big difference between these two. So when we go to talk about, we'll just say the data is either the same or different, but you can even pinpoint which part of the data is kind of causing this to make everything go wrong, that makes the distribution wrong. So kind of keep that in mind. These are other tricks you can use to figure this out. All right, so let me erase some of this stuff here because it's kind of a hot mess at the moment. So I can get my test, because I don't have any room to do my p-value at this point. So let me write my test statistic up here, 13.106. And then I forget, does this give us an alpha level? So it did not give us an alpha level, so that means we're going to do alpha equals 0.05. So we still need to go to the chi-square distribution and figure out what our alpha level is so we can compare it to our test statistic to see if it looks like we're going to fail H naught or reject reject H naught or fail to reject H naught. So in this case, let's go to our alpha level. Oh, I got to calculate our degrees of freedom too. So our degrees of freedom is going to be, we've got 1, 2, 3, 4 columns. So 4 minus 1. So we've got a degree of freedom of 3 and alpha of 0.05. So if we go to our chi-square distribution table, so we're looking for this alpha, we're looking for this degrees of freedom. So our magic number is going to be 7.815 in this case. So let me go back to the graph. So what that means is, so again, so this little shaded part here is going to be our alpha equals 0.05. This is 7.815. So if we're in this section, we're going to reject H naught. If we're over here, we're going to fail to reject H naught. And so where does our chi-squared statistic live? Well, it's going to be way over here somewhere, 13.106. So it looks pretty safe to say that this is going to be a reject H naught. But again, we should do the p-value just to check, just make sure. So in this case, we're going to do chi-squared CDF, our 13.106, comma, 100,000, comma, our degrees of freedom, which were 3. So let's throw these in the calculator real quick here. So second vars, chi-squared CDF. So 113.106, comma, 100,000, comma 3. Oh, how in the world did I get a value in front of that? That's no good. Let's try this again. You should never get a negative value. So if you get a negative value, that means something's wrong. So apparently I had a number in front of this multiplying it together, which is no good. There we go. So 0.0044 is our p-value, it looks like. 0.0044. So in this case, that is definitely less than alpha. So that means we are going to reject H naught. So in this case, our conclusion, since our p-value less than alpha. Reject H naught. There's sufficient evidence to prove these two distributions are not the same. And so again, not that we write it down, but we can actually see like where this breaks down is because of the military. So you can look at it at the numbers, but it's kind of hard to tell whether like it's statistically significant or not. So, but when you look at, well, I erased it by now, but when you looked at that, our sum, you could really see that that's where we were going to end up blowing this value up and making it really, really big. All right, so again, is it just like doing the test for independence? Takes a lot of steps and stuff like that, of course. So I've got a bunch of practice problems for you guys to work on here. So otherwise, I'll be around class all day tomorrow if you have any questions. So good luck and let me know if you get stuck.